Thank you. Hello, everyone, and thank you for being here with me. And I hope everyone had coffee. We have a lot to discuss. So, just a little bit about my background. I've been a tester for about 18 years. I'm currently the QA tech lead on the agent development team at Secureworks. And some of my hobbies are blockchain and learning new test tools and learning more about rapid software methodology, rapid testing software methodology. So what is Secureworks? Secureworks is an American cybersecurity company founded in 1998, became part of Dell Technologies in 2011, approximately 4,000 customers in more than 50 countries. And some of those are mid-sized and Fortune 100 companies. And some of our noteworthy products and services are XDR platform, managed XDR, and counter-threat research. And this talk will focus on the Secureworks agents themselves, the actual part that does the threat detection and analysis. So what is an endpoint detection agent? Typically, it is a static binary that can be installed on Mac, Linux, and Windows machines. It's capable of monitoring different types of system events at the user, the administrator, root user level, usually composed of drivers or system extensions that have access to the kernel space or the root or the user space as well. So some examples of that in the open source community are the extended Berkeley packet filter, which is also called eBPF, and the Falco. So here's a visualization of how an endpoint detection agent would work in a customer environment. So you have your customer machine, and you have your endpoint detection agent installed in their environment, and that would be communicating up to your XDR platform. So what you see here is actual telemetry being sent to that platform. Some of you may be thinking, well, isn't that just antivirus? It's really cool. But traditional antivirus versus cloud-native XDR solutions is it's a bit of a, there's a difference. Antivirus and malware capabilities, that's only a fraction of what cloud-native solutions can do. So commonly encountered antivirus programs are usually just limited to that threat detection scope. In their threat detection scope, antivirus can be evaded. Antivirus can't detect coordinated or sophisticated attacks. Antivirus can handle isolate enterprise-wide threats at scale, and it can go on. So think of an endpoint detection agent as the tip of the XDR spear. You're doing threat monitoring at an enormous scale, and imagine millions of endpoints, and all of those endpoints are feeding machine learning assisted detection platform processes and installed on millions of customer host machines with different types of hardware profiles. And they're used on different types of operating system distros and kernel versions. So threat actors constantly adapt, and they improve their strategies all the time. And some of them are connected to hostile nation states. So who here has heard of the MITRE ATT&CK framework? Anyone? I see one hand up. I knew you would know. And okay, so MITRE ATT&CK Team is basically a US government-funded nonprofit organization. It's currently tracking 135 threat groups. And one of those threat groups that is being focused on for 2023, MITRE Enterprise Evaluation, is the Turla threat group. And has anyone here not heard of the SolarWinds hack? Well, the whole room knows. That's good. It was a supply chain attack on Microsoft Cloud Services, and it affected 200 organizations at least, including US government, NATO, etc. So Secureworks agent testers need to be flexible and adaptable. Our strategies need to adapt and explore new approaches, and frequent experimentation and research is vital. So we do a 50-50 approach. Half of our team is very skilled security researchers, security testers, pen testers, and very seasoned exploratory testers. The other half is focused on rapidly building out automation. So one of the core components of Secureworks test strategy is robot framework. That's at the core of what we do. And we have 5 primary strategies we tend to focus on to progressively push our endpoint agent to the edge and see how far we could take it. We want to do that before it reaches our customers' machines. So the first strategy, testing agents in various machine types. Virtual machines are the most flexible, but hardware testing is still a required part. So we tend to focus more on this economical choice through virtual machines, but we also have a hardware device lab that we're trying to build out. And running on various types of local VMs is very useful for our exploratory testers and automation developers. So dedicated VMs in AWS and Azure are also very useful, and we want to be able to have these persistent environments for our testing needs. Automation developers who work in Robot Framework at Secureworks, they tend to be running it directly on their own personal hardware, or running it inside their VM, or running Robot Framework from Docker containers. Here's an example of agent and Robot Framework running directly on our personal work hardware. So as you can see, well, we have our QA toolkit, which is, of course, primarily Robot Framework. And we have the agent under test. Other than the built-ins and standard library, Robot Framework libraries, we also have our own custom telemetry bundle reading keywords as well, which is very crucial. And here's an example of Robot Framework running inside a VM with the agent installed. We primarily use VMware tools. Again, similar configuration, but in a VM. And here's an example of a Docker container testing a VM and also accessing that VM through the SSH library. Similar concept, but with a Docker container and the agent being interacted with from the outside. In our second strategy, we take what we learned from our first and we scale it out. In our case, we use GitLab. These GitLab pipelines have short-lived ephemeral VMs, or they call them GitLab runners, in an AWS and Microsoft Azure. And we like to visualize those results, the reports, with the GitLab's built-in JUnit XML report feature, which Tattoo showed in his short presentation about the XUnit results, the very useful XUnit Robot Framework results. And that's just a matter of changing the YAML file and enabling the XUnit output from there. So here's an example of the Linux runners. Scales out to 18 different runners. That's some of them are running multi-core and some of them are running single core. And it's 9 different distros. One of the key things to have here in this type of configuration, you want to make sure that your robot files are working as they should. So I recommend a linting stage to stop right there when it detects any kind of syntax problem in your robot files. That's a very simple thing to add. And this is an example of a GitLab runner test report. It's a very simple thing to add to your GitLab YAML pipeline file. Just need to have your path set up here and also the reports and the JUnit field right there. One of my favorite parts of this is it shows you the details at very good detail about the output of your error or whatever failure it found and how many times it failed within the last 14 days. It's a very cool feature. So strategy 3, and we want to push your agent as far as you can, and it's building up until like this progressive punishing test of Gatling and other stress tests. I prefer Scala for this kind of stuff. So we perform these types of tests using Docker containers, local VMs, and Azure VMs. So here's common components. Of course, where would I be without Paybot? Paybot is at the heart of this parallel running stress test suite. I use another one called Ammonite. It's a Scala scripting framework. Gatling, of course, for HTTP load testing at very high scale. And Prism, which is a mock HTTP server, which is simply a binary. It's a static binary. You feed it an open API specification Swagger file, and it's very simple to set up. So here's a visualization of strategy 3. I have this is using Phoronix right here, and also running the Scala scripting. So the Phoronix test will be making the disk busy while also creating files, overwriting them, and deleting them. The goal here is to try to crash the agent. and try to see if there's any type of unusual CPU usage. So the trick is to maybe play around with that and try to run it for 24 hours or more. Also, from our NetFlow telemetry perspective, this is a visualization of a Docker container running Gatling, and also your mock server running inside a VMware VM, and your agent installed inside of it. Same concept, try to run it for hours or more, or days if you can. And from here, you can see we have the same concept of a NetFlow telemetry stress test using, it could be Azure or AWS. In this particular example, we've used Azure. And we had two options, one load generator pointed to one target, or two load generators pointed to one target. So in our case, we opted for option one. And option one is sending 2 million requests per minute. And it's also trying, again, its best to crash that agent in its environment. Now here, it barely made it to like 5 to 6 minutes. When we did option two, it barely lasted for a couple seconds. So option one was our best choice and gave us more useful data. And we found out that our agent only spent about maybe at most 0.8% in CPU usage. So building on top of strategy 3, we have our strategy 4, which is even more torture testing with chaos testing, model-based testing, etc. So some useful tools to that we use commonly are Toxic Proxy, GraphWalker, and of course the Robot Framework String Library. So we take those components and we try to use it in very interesting ways. So it's better to demonstrate this in some code. It's an example of a network outage chaos test. In this test, we have here the repeat keyword, basically taking this generate network telemetry and random network outage chaos test. I have the name of the interface, and I am basically randomizing the amount of seconds to first, before I turn on and off, and do it again. And I run that for however many hours I want, or days. The trick here is to try to make the agent crash and see what kind of funny things it does. And this is, of course, a visualization of it. Another thing that's great about Robot Framework is it plays well with other tools that are in the testing ecosystem. GraphWalker is a model-based test framework. It's just a simple jar file. You give it a GraphML file, and that will generate a CSV file that you could turn into possibly a list of keywords to run. And of course, your vertexes are your checks, your edges are the actions. So imagine taking that chaos test, running it in PA-bot, and then running that model-based test side by side in that same test environment. You could get some interesting results out of that. Chaos testing pairs well with stress testing as well. So that Toxic Proxy tool I was talking about, let's go back a bit, sorry. That Toxic Proxy test I was talking about has 8 different types of disruptions, slowdowns, delays. Here's an example of it. It's a little hard to read. I recommend you go check it out. So try that out with your load generator example here, and you'll get some, possibly get some interesting results. And with MITRE ATT&CK, our strategy 5. So MITRE ATT&CK framework is essentially a collection of different tactics and techniques that threat actors would use on vulnerable systems, vulnerable setups, and enterprise-wide environments. I really highly recommend all of you check that out. And a friendly warning, please do not attempt any of that without getting the permission of your CISO or your Chief Information Security Officer. And always make sure you have guardrails set up. That's very important. And the primary tool we're concerned about is Atomic Red Team and its test runner invoke Atomic Red Team. And the core pieces that we focus on with this is data driver, paybot, and Vagrant. Yes, Rainer Roner's data driver, huge help here. And of course, Mikko Korpelas, paybot, who could live without that? And Vagrant is a huge help when you have a lot of Linux configurations you have to deal with. Of course, your telemetry reading keywords. So here's an example of 2 examples here of one with Paybot, and of course our Vagrant automation setting up the environments to be ephemeral, only short-lived, but because if you run the full suite of MITRE tests, you will be messing up your environment, and you want to be able to clean up and start over again fresh. Highly recommend you use Vagrant for that. So plays well with Paybot. It's a very, very useful tool. It's Vagrant's quite old actually too. It still works well. And option 2 is, well, you have your tester configure, set up your Azure environment or your AWS environment if you prefer that. But the advantage of Azure, of course, is the Windows environment you get to test in. So when you're triggering that, it's by hand, and having your MITRE scripts set up ahead of time in your data driver CSV files. So that's split up against 4 CSV files. So when we take our option 1, we had noticed that a 8.5-hour test was reduced down to approximately 3 hours. So that's a huge win. And PABot was crucial in that. And yeah, that's the Linux test run example here for CentOS 7. And now I'll play a demonstration for the Azure version of this.
Hello, this is Joshua Garospi, and I will be walking you through the MITRE automation that was created for this specific hackathon project for XDR searches for Windows event detections. This is intended to help us test end-to-end the Turla alerts from the XDR side. So by now you would have seen the slides that Neil and Ashok have shown about the alerts work that they split amongst themselves. So I will be walking you through the automation contribution that I have done for this hackathon project. It involves the Atomic Robot Sandbox toolkit, in which I've created a MITRE evaluation Turla branch. In this specific branch, I've set up automation that will run invoke Atomic Red Team, which is a test runner created by the Red Canary Co. group that also created the Atomic Red Team repo you see here. Now, this is the index.csv file for Windows that eventually holds all of the TTPs, the tactics and techniques that are focused on in the upcoming February MITRE evaluation, which is focused on Turla. There are a total of 1,022 of these tactics and techniques, and they all have their own technique number, of course, and their own test number. And specifically what I focus on in the automation is the test GUID, which uniquely identifies every single test in this index.csv file. In this robot framework data driver file, there are more than 500 filtered Turla-specific tests, and I am identifying them each uniquely by their GUID. This work is distributed across 4 different Azure VMs, as you can see here. And I will demonstrate how I start these tests. Just an FYI, these tests are not checking the telemetry bundles. They're meant to be an end-to-end check that would require someone to look into the alerts UI from the XDR side. So this robot framework data driver automation will run in a loop, and I will show you the end results of these tests, the checks that were made. So This is a screenshot of a check that Ashok performed in front of Neil and myself. So this.
So skipping that part and zooming in on these results here. This generated around, you can't really see it, maybe you can, 54,000 plus events, and they're all Turla related. So this is very, very crucial to validate that our agent actually is catching some Turla related alerts. So some closing thoughts. Testing is hard work. I think all of us can agree, because here I see some of the world's greatest testing specialists gathered in one place, and testing endpoint detection agents is not an easy task at all. And I know there's some here that know how hard it is to test agents. Hopefully these strategies were useful to some of you. If this is your first time seeing this type of content, I hope it was informative. And if you are interested in any unrelated and generic automation examples that were utilized in my work, you can find it here in the generic Gatling and Scala library that I wrote here. And the model-based testing example found here in a previous workshop I did. Also, fun fact, this generic Gatling Scala library is also, you could search it from the robotframework.org website. And if any of the XDR and endpoint detection agent topics you've heard here are interesting to you, and security is a topic that you enjoy, Secureworks has opportunities. Thank you to all of the Robot Framework community contributors all over the world. You know who you are, don't need to name you. Your hard work helped me convince my team to keep Robot Framework around for a long time, and I hope that you're proud of that your work is helping to secure human progress. That's it. Questions? I left a lot of time for questions.